Okay, so this is the portion of the chemical formula. And for chemical formula, right, we must first identify what are the charges of the elements. So what happens is number one is the metals, right, they are from group 1, group 2 and group 3. However, for non-metals it's generally from 4, 5, 6 and 7. Group 0 are known as noble gases.
Yep.
And the individual elements, they will either gain or lose electron to achieve the noble gas configuration or the stable state configuration. Now when this occurs, right, what happens is for metals from group 1 you will tend to lose 1 electron. When you lose 1 electron, you have an overall charge of plus 1 but in the exams you just put as a charge as plus. For group 2 you will lose 2 electron, you'll be 2 plus. Group 3 is lose 3 electron, you'll be 3 plus, and so on and so forth.
So the ones that lose will be positive, the ones that gain will be negative.
Negative, correct.
Okay.
And then the charge, right, you tend to write the number first and then the charge at the back. Okay. Now when it comes to valency, valency from Roman numerals, in the sense that you have to be like capital I and capital II. This is mainly if they ask you to write group numbers. In the event that chemical formula, right, you also write the Roman number in the naming. Okay. For chemical formula, however there is a group that you have to remember, which is the valency of polyatomic ions. This one you cannot find from the periodic table, and it has only to be available through memory. So the common ones that you need to know is, like, for example, ammonium ion. It has a plus charge, while for negative ions, right, your nitrate is NO3 minus. This one, usually the nitrate, it comes from nitric acid.
So the only one that is positive from the memorization
is ammonia. Then of course hydroxide comes from your alkali. Carbonate ions, that comes from your carbonate salts, they tend to have CO3 2 minus. And then the sulfate ions generally come from your sulfuric acid. Okay. Now how do we go about combining or forming the chemical formulas? Number one is by writing the charge at the top, right? You just do a crisscross. Then you will actually be able to write the formula. Do take note is you have to remember to bracket the whole item. If it's a 3 in this case, or onwards.
Only
Okay.
3 and onwards.
No, 2 and onwards. It's just that 1 you don't write. There's no point. And then in the event that both have the same numerical value, like magnesium 2 plus and CO3 2 minus, the 2 and 2 is the same, so it will actually cancel out each other. It will just be MgO CO3. Okay, so this is for the part of the chemical formula. After you have actually write the chemical formula, you are required to actually write down the ionic compound, like the naming. So for naming wise, what happens is you just need to take note that it usually ends, if it's an ionic compound, it ends with an IDE at the back. Okay, and then you use Roman numbers, numericals, to label the group number for elements that can exist in many transition state. Okay, and then the rest should be okay. So in this case, the other one for naming, right, you tend to use the word mono if it occurs if you only have one particular part of the molecule or atom. Di for 2, 3, tri would be for 3, tetra would be 4. Most of the time you will not need to hit more than 3.
I don't remember tetra, I only remember after 3.
Yeah, so as I say, tested mainly until 3, but if they test 4, you just put tetra. Okay, more than 4 it'll be like pent and things like this, which rarely comes out. Okay, only two there are a few special names given to compounds like water, H2O. This doesn't follow the naming form, like for example H2 and the O. Okay, the other one is ammonia, which is NH3 gas. So do take note, ammonium salt is actually NH4
NH4 plus.
plus. Ammonia is NH3. For any chemical formula,
Ammonium is NH4 plus.
yeah, that's the charge of the ion. For any chemical formula, there shouldn't be a charge at the top. It should balance out. Next is consideration of how to go about balancing the equation. So after you have written the chemical formula, you have to put it into a string of equations. So there is either the naming, which is which we call word equations, or if it's a chemical equation, you'll be using chemical formula.
Okay.
For chemical formulas, you are required to balance it by writing the number in the front. Or for word equation, no need to balance. Okay, so in this case, let's say we look at magnesium plus oxygen to give magnesium oxide. So if you take a look, right, if I ask you to write the word equation, it will just be magnesium plus oxygen to give you magnesium oxide. Then it ends off like this forward. However, for a higher level one, you will need to be able to write chemical equations. And one common mistake is students never balance. So if you realize that after trying multiple trials of a number you cannot balance, right, then your chemical formula, one of it is wrong. So first of all, when you start balancing, you write the equation without any balancing first. Write the chemical formula based on the word equation, then you string it together. Next, you physically count the number of elements in that particular equation. A rule of thumb is you start off with balancing first the group 1, 2, 3 metals, then followed by the 4, 5, 6, 7 non-metals. No, not noble gases. Noble gases is only for group 0. The non-metals. Then after that, you go and balance for hydrogen or oxygen.
Do you do the oxygen first?
That one you have to try and error. Never do oxygen or hydrogen first before the metal. It should be done after the non-metal. Okay. Then after you have balance, now one thing about chemical formulas to take note is they don't really need to write the charge. So what actually happens is this number here represents the whole molecule. Like this 2 represents for MgO. Okay, it's not just for Mg. If you want to write just for Mg, you just have to write a superscript at the bottom. But this is also wrong. I mean, in terms of there's no such thing as Mg2 lah. Okay, so this one just take note. And you can see that there isn't a need to write any charge at the top for chemical formulas. Later on, if we will touch on ionic equations that involves that particular charge. Okay. Then after you have placed the number one by one, you always count the number of atoms available. The number of atoms in the left side must be the same as the right side because atoms cannot be created or destroyed suddenly like this. Okay. So what is the anatomy of a chemical equation? The anatomy of a chemical equation is the left hand side before the arrow. It tends to be known as the reactants. So that's where you put all the reactants. On the right hand side is actually all the names of the products. Sometimes on top of the arrow, right, you will put the conditions.
As in like the process?
Like for example, does it require light? Does it require heat?
Something like the photosynthesis.
Correct.
So for the photosynthesis one was sunlight at the top.
Yes. But don't use sunlight. You put light energy. Then below you put chlorophyll for the equation of photosynthesis. Okay. So these are how you go about from word equation to chemical equation. So after writing a generic word equation like this, like for example, let's use this particular equation as an example. So sodium, the charge of sodium is actually Na plus, hydroxide is OH minus. Iron 2 is Fe2 plus, chloride is Cl minus. Sodium is again Na plus, chloride Cl minus, iron 2 Fe2 plus,
OH minus.
OH minus. Now this one is to help you write the chemical formula. So sodium hydroxide it will be NaOH, then you can erase away. The other one is FeCl, right?
Yep.
So it will be Fe, you cross, it will be FeCl2.
Yep.
Then sodium chloride.
NaOH.
Yep.
Because both are plus.
Okay, then Fe2OH it will be Fe bracket OH2. Now with this in mind, you have already written the
Wait, what if the Fe, the charge was negative?
Fe will not have a negative charge.
No, but what if?
It will never.
Never. Okay.
It can never happen.
Okay.
Okay, so if you draw the arrow and you write a plus. Okay, next is what is the state symbol. So for your acids and alkalines, they are always in the aqueous state. Okay, now second thing is sodium chloride. It's a soluble salt. Like if you use common salt, you put into water, it will dissolve, right? That's why it's always in aqueous. Okay. Then in this case, in the latest chapter, you will learn that there are some that is actually not soluble in water, so you put as solid. And there you have it. This is the chemical equation. But there's one more step that you have to do, which is to you have to balance it. You have to balance the equation. So let's look at the metal first. Metal for sodium is balanced, so check. Second, what about your hydroxide ions? You see there's two OH, right?
Yep.
So this must have a 2. Then you realize that, oh no, your sodium is not balanced, so you have to rebalance it again, so you add a 2.
Then your Cl will also have a need to.
Balance already, what?
Oh.
Right or not?
Iron.
Then iron also balanced. So this is the final equation. Cause sodium you have 2, check. Hydroxide you have OH2, you also check. That means 2 oxygen, 2 hydrogen, both are the same. Fe, 1 Fe, 1 Fe, 2 Cl2, 2 Cl, 1 Cl2 and 2 Cl. So it's the same. So done. So this is the balancing of the full chemical equation. Understand? So writing of ionic equation comes in when you know that that particular compound is not able to dissociate to become ions. So let's look for an example of this is sodium nitrate, whereby when sodium nitrate dissolve in water, it will form your sodium ion as well as your nitrate ion. Okay, how about this one? Over here you see that water cannot become ion form, right? Because it's H2O, so that's why it remains the same. Anything that is aqueous can become ions because it shows that it can dissolve in water.
Okay.
So what we will do is Na plus OH minus.
Also, to be a ionic, we call it ionic equation. They have to be aqueous.
To be ionic equations is a representation of what are the ions that are involved. So I'll show you the steps, then you have an idea. So this one you break it down, aqueous. So Na plus NO3 minus. Correct? Now you see that there is some similar ions in the left side and some similar ions in the right side. So what happens is, if it's not a liquid, it will remain the same molecule, or solid, same molecule, gas, same molecule.
Okay.
Next, what you need to do is to remove common ions in the left and right side. So Na is a common with the Na plus here, right? You remove it. Okay, so what we are doing is we are simplifying the equation. Then OH minus, there's no OH minus on the right? So you keep. H plus, there's also no OH plus in the right, so you keep. NO3 minus, there is 1, right? There's 1 here, right?
Yep.
Left and right, so you cancel away. And therefore, this is the final ionic equation.
Cancelling out spectator ions. Spectator as in like they are extra lah.
No, they are just there but not contributing to the reaction at all.
So if there were two of the same thing, then we can just remove both of them.
Yeah, that's what we just did.
Ah.
Yeah. So you cancel out lor. So what is left is those ions that do not have in both sides.
What if you didn't cancel them out?
You'll be marked wrong.
Oh.
Like if you leave as Na plus here and Na plus here, you'll be marked wrong.
But only if they are both the same, then you can remove it.
Must be the same ions. That means that means even though they put here as you put Na plus and then you put here NaNO3, right? You cannot cancel out because Na is already attached to NO3.
Oh.
But you only cancel the charged ion. That means those with the superscript. They must be exactly the same in the left and right side.
So like if there's Na plus on left hand side, which is 1, then there should be another 1 Na plus, right?
On the right, then you can cancel out. If there isn't, you leave it. You don't cancel.
So there was 2 Na on the left, then 1 Na on the right, then you just leave it.
Wait, when you say 2 Na meaning what?
Like there's 2 Na charge.
Okay, so it's like let's say
2 Na.
okay, so let's say it's 2 Na plus like this.
Yeah,
right?
like that.
And there's 1 Na plus like this,
Yeah.
right? In this case, right, you just cancel one of it.
Oh, okay.
That means leaving the other one. You remove one, you have to remove one the other side.
Or something like that math thing, right? It's one math thing where the times above, right? Then
I think it's factorization.
something like yeah.
Okay. So and that's all for this particular portion for chemical chemical equations.
That's it?
Yeah.
All of this?
Yes. But what is important is you need to practice. So we will
Try.
do some practice.